Okay, in Math 65 today, we're going to talk about two other ways to solve systems of equations. So far, what was the only way that we have learned to solve a system of equation? In 4.1, what did we learn? We solved systems by graphing. Good. Okay, today we're going to learn that there are two other ways to solve systems of equations. Does anybody have any guesses as to what they are? Yeah, algebraically, which is actually, there's two ways to do that. The addition method and the substitution method. Okay, why do you think we don't want to solve all systems graphically? Right. Sometimes it's like the decimal one we just looked at, the decimals, do you think you would be able to find the answer if your answer was a decimal? Not unless you're using a graphing calculator and it can get that fine, but if you're graphing it by hand, and sometimes actually your solution could be a fraction. If you're not using the right kind of scale, it's going to be impossible to figure out what that point of intersection is. So we need to have another method, and our second method is algebraically. I said we had three methods. What I really meant by that is we have two different forms of algebraically, okay? And they're going to, each one is going to lend themselves differently to different scenarios. So the first method is algebraic, or is addition method. It's also called the elimination method, okay? It's best used when, and I'll actually let you, I'm going to do the steps for you, and then I'm going to let you get this from the PowerPoint, because I don't want to write down the steps. I might have them differently than the PowerPoint does. But essentially, I'm just going to show you what's happening here, and we'll write some steps, and then you'll go back to that. Okay, solve the system using the elimination method. So the very first thing is they both have to be lined, your variables have to be lined up. So actually, I guess I would say, maybe I will do the steps up here. Well, no, I'll just do them over here. So step one is going to be to make sure both equations are in standard form. And that's ax plus by equals c. Do you see how this is written? It's not in slope y-intercept form. Does that make sense? Okay, and then, so you want all your variables to line up. Then what we need to do is we're going to be adding the two equations together. So that's why it's called elimination, because what is going to happen if I add 2x and negative 2x together? What am I going to get? 0x. So these are essentially eliminated. You see that? What happens when I add the rest of it together? What's y plus y? 2y. What's 8 plus 4? 12. What I've done is I've added the two equations together. I've eliminated the x variable in order to solve for y. Okay? Now I only have one variable. Can I get y by itself? What would I do to get y by itself? On both sides, we get y equals 6. Now, is that the solution to the system? We want, when we have a system of equation, the solution is going to be what? Yes, an ordered pair. So if I have y, what am I going to want to do to get x? Yes, essentially check. You're right. We want to now, so actually what did we do? We added to eliminate x, and then 3, we're going to plug in y to get x. And we want to do it in both. So if I do it in both and I get the same x value, I count that as a check, right? So it's kind of like a check. Check number 1, I put in 2x plus 6 equals 8. Does everybody see why I put the 6 in? Okay, for y. So I'm plugging it in. I want to solve. This is equation number 1. I want to solve for x now. What do I do to solve for x? 2x equals 2. X equals, what would x equal? 1, right? How did I get 1? 2 times what is 2? Yeah, I just didn't write the divide because I was like, well, if the only thing I can multiply by 2 and get 2 would be 1. Okay, this is going to be check number 2. I'm writing it over here. Check number 2. I'm taking the second equation, negative 2x plus 6 equals 4. What do you want x to be? When you solve for x, what answer do you want x to be? You want it to be a what? What number, though? Negative minus 6, right? Negative 2x equals negative 2. What would x equal? 1. So what is the solution? 1, 6. Why do I have an ordered pair? Why don't I just have x equals 1? Yes, there's 2 variables because there's 2 equations, and I want the solution to be an ordered pair. Any questions on how we got that? Okay, that's the easy version. Now we got to step up the challenge level a little bit. If I were to just go ahead and add these together, would any of my variables eliminate? Oops. No, they wouldn't, right? I would get 7x, negative 2y. I didn't eliminate any. So I have to change, for this problem, the difference between this problem, okay, and this would be step 2 here, would be I need to change one equation so that the coefficients are equal and opposite. Okay? So which variable would you want to eliminate here? We have to pick one. Is it going to be easier to eliminate the x's or easier to eliminate the y's? I'm going to say it's going to be easier to eliminate the y's because if I multiply this whole entire equation by 2 times 2, right? I'm just going to put parentheses. What's going to happen to this y, the coefficient of y? Yes, it's going to be the opposite number, right? So if I multiply everything by 2, I get 4x plus 4y equals what? Does everybody see why I got that? I'm going to add that to the first equation. 3x minus 4y equals 13. I'm going to add those. Why don't I have to change the first equation? Yeah, I have, now they have the same, right? I changed the second one, changed one of the equations so the coefficients are equal and opposite. Now these y's eliminate. If I add them together, 4 plus negative 4 is 0, yeah? What are the x's? What's the coefficient of x? How many x's do I have? 7x, and what do I have here? Oh, I love it when it works out evenly, right? Okay, now what do I get? X, what am I going to do to get x by itself? X equals 3. Am I done? What do I need to do next? So we're going to plug in, this time we're plugging in x to get y. So we're going to take our original equations. Number 1, 3x. Oops, I should have put, what do I need to put in for x? Yeah, I needed to put 3. So let's just correct that. So here's 3. We're plugging in 3. We get 9 minus 4y equals 13. What should I do next? Yeah. Equals 4, right? What's y equal to? What number times negative 4 gives you positive 4? Negative 1. So that's check number 1. I'm going to go ahead and plug the x in to the second equation. I'm always going to go to the original equation. 2 times 3, so this is check number 2, number 1, number 2, not to get confused with that 2, plus, 2y equals 4. 6 plus 2y equals 4. What's my next step? Subtract 6. Kind of should have put it over here, huh? 2y equals negative 2. What does y equal? Negative 1. So what's the solution? Here's where students often miss points. They don't write the solution. What's the solution? 3, negative 1 is the solution. What kind of system is this? Dependent, inconsistent, or consistent? Consistent. It's consistent because it has one solution. Remember, consistent versus dependent versus inconsistent? Inconsistent, the lines are parallel. Dependent, the lines are the same. Yep. Okay, now let's look at this one. What do you want to do to set it up? What do we need to do? Decide which variable you want to eliminate, and what could we do to set it up? I'm not going to do the whole problem. I'm just going to get you started. Yes, a least common multiple. It's kind of like finding a common denominator, a least common multiple of 2 of the coefficients. So, and actually it could be either one. You could decide to eliminate the x's, or you could decide to eliminate the y's. Right now, I have a preference for which one I would want to eliminate. Do you? Which one? The y's. Why the y's? Ah, bingo. You don't have to change the signs, right? So if I wanted to eliminate the y's, what would I need to multiply the first equation? And why is that? You're going to multiply the first equation, oops, that's a 4, by 3, okay? You're going to multiply the second equation, 5x minus 3y equals negative 29. You're going to multiply it by 4. Yes. It's essentially the exact same thing if you were going to find a common denominator between 3 and 4. Let's just pretend that you wanted to eliminate the x's, okay? What would you have to multiply the first equation by, and what would you have to multiply the second equation by? 5x minus 3y equals negative 29. What could you multiply the first one by? What could you multiply the second one by? Yeah, but they would have to be opposite signs, right? So one of them would have to be a negative 5, and the other one would have to be a positive 3, or vice versa. But you would have to change the sign, which is the reason why it's a little bit easier to eliminate the y's, because you have that situation where they already have opposite signs. So you could literally do it either way. One, you're going to be solving for x. The other one, you're going to be solving for y. But you're going to get the same answer either way. Any questions before we end this video right now? Yes. Yes. And in math, we always want to try and take the path of least resistance. A lot of times people make sign errors. So that's why I would have preferred, if I was doing the problem, I would go for the y's, because this one already has a negative and that one already has a positive, and then I don't have to worry about any, because like I would say 90% of all mistakes in a math class are usually to do with positive and negatives. In all my math classes, I'm not kidding you. positive and negatives. Can you imagine? And it's something so simple, but yet it really throws people off. Okay, so let's have you guys try